Hi, it's Bruce, and welcome to my Colorado lab once again. And what we're going to talk about now is something a little bit different. This is an encased Beckman Helipot. This particular one is a 1,000 ohm Helipot. Has a linearity of 0.05%. It's a 5-watt pot. And what is particularly interesting about it is this dial system as well. I mean, a lot of us have probably seen the 10-turn dial traditionally placed on a pot, which would look something like this. You turn it 10 times, and there's a counter that will go up in a little faceplate here. This is also a counter similar. So like here we are at 0, and then as I dial the wheel, there'd be 100 ohms, 200 ohms, 300 ohms. You get the idea, up to 1,000 ohms. And it's a really interesting, easy to use because everything is so large. It's easy to manipulate very finely. The spindle of the helipot, and you can fight the torque and everything, and with some ease. Now I've opened it up just to show you. It's really nothing complicated, but it is something worth having. Now here it says Helipot, Beckman Instruments Incorporated, Helipot, Model A R1K L.05. And then the rest of it is the dial itself. I am going to add the third terminal on this, and I will divide the wire, the blue wire that's on there now, and provide all three terminals access so that I can use it as a voltage divider as well. Now, right now it's a variable resistor. It was worth investing a few bucks in the case and then mounting the thing in there, and it'll give me a nice handy little variable resistor with the linearity that it has, the 5 watts value that it has. It's a nice piece of gear for a bench. I'll be using it. So it was invented by Arnold Beckman, I don't know, back in, I guess he first invented the helipot in the late 30s when he was working on a pH, I think it was. Maybe it was something for pH. But anyway, and then the government contacted him during the war. They needed the helipot to work with their new radar devices, and suddenly he was in great demand. And over the years, the helipot wound up being one of the biggest money makers for the Beckman Corporation. I think at one point it accounted for 40% of its profits. That's what I read online. Okay, so what you might notice now is that I did add the third pot point. So now I've got all 3 points. I've got the center wiper and then the 2 ends. And that allows me to use this as a voltage divider, which I'm doing right now. Basically, I've got a stable source of voltage. And it honestly isn't real critical what voltage. At the moment, I have 7 volts coming in. I had 10 a few minutes ago, but I fed 1 lead of that through this adjustable resistor. This is a decastat variable resistor, so think of it as a resistance box. The only thing that does for me is it gives me a lot of variation of resistance that I can use to create half of the divider that this potentiometer is a part of, the other half. And so I've got a 1K in series right now with apparently 5,952 ohms. And I'm feeding the 7 volts in. There's a little bit more resistance than 1,000, even though it's rated at 1,000. I think it had a 5% marking. Maybe it was, I don't remember. But anyway, the linearity is the critical thing on the pot. The fact that there was a little bit of extra resistance, is nullified by the adjustable resistor that I'm using over here. So if it had been exactly 1,000 ohms, then perhaps this would have been 6,000 ohms exactly for 7 volts input, and I would have had the dial calibrated such that at 0.9 I got 0.9 and 4 zeros. But this has a little bit more resistance in it than 1,000 ohms, so I had to decrease the resistance on this resistor in order to make up for that and get the calibration right. So I was able to do that. So this gives me a really handy adjustable divider for the quick situations like where I'm breadboarding something and I want to determine what it needs to be, or just provide a voltage that I couldn't get a handy source of. So let's go ahead and dial in 7. Alright, that says this is actually 6. And there I am, 0.04, 0.03, 0.01 actually at this point. 0.01 millivolt, or 10 microvolts from 6.6 volts perfectly, and it's reading 0.6, just a hair under 0.6 on the dial. So that's working pretty good. If I disconnect the voltage source and I connect this little wire to the thing, I can use this as a variable resistance, and I have that available too. So that's a nice handy little gadget. Thanks for watching.